Hi, welcome back to Cinderella Math. Today's video will be operations with I. This is probably like an Algebra 2 level, but could be a nice review for a pre-calc or even a nice review before SATs. So yeah, welcome in, and I'm going to go through all the operations with I. First of all, I'll give just a quick rundown of what I is. I is the imaginary unit, which basically was invented to answer the question x squared equals -1. So that did not have an answer until this imaginary unit was invented. If you take the square root and take the square root, in earlier math classes, probably like Algebra 1, you were told this has no answer. This actually has no real answer. But once we get into imaginary numbers, x is I, and still you do a plus minus, typically, if you're solving. Okay, so that is where I has come from. So definition of I is it is the root of -1. Okay, so we can get into it by starting off with operations with square roots, and in particular with the negative square roots. So let's say -√5 times -√10. So you might be tempted to just go ahead and multiply those and get root +50, and that would not be right. You do want to go ahead and pull out the I. So really, this is 5 times -1, root, and that'll give us I √5. Always I to the front. And then this one really is √10 times √1. So that's really I √10. And again, always I in the front. Still times. Now, typically I don't actually write that intermediate step out. If you're just starting with I, you might want to. After a couple problems, you probably won't need to anymore. Now, let's multiply. You multiply the outside by the outside, so that's I squared, and the inside by the inside, so that's √50. Now, I squared is very important. I'm going to call him a superhero. He's so important. And a superhero often has a disguise. I squared is -1. That is his disguise. So you want to change him. Why is this the case? Well, we just said the definition of I is root -1. So if you do I squared, it's root -1 squared, but that just cancels and it's -1. So I'm going to call him our superhero. He's so awesome. He's going to turn into his superhero ego here, -1. And 50 is not a perfect square, but let's see if he breaks down. That's 5 times 10, which is 5 times 2. Simplifying a root, we're going to pull out the partner. So that's going to be 5. And the lonely prime number will go back in. This will give us, multiply this together, -5 √2. Answer. Okay, if you simplify roots differently than me, feel free. I just do the little number tree method. And then if it's a partner, if it's a couple, it moves out of the house. And if a prime number does not have a partner, if he's single, he stays in the house. All right, I'll do one more like that. Oh, goodness, let's do -8 plus 5 root -9. So that would be -8 plus 5. And then this is really root -1 times √9. You can always pull it out like that. But root -1 is I, and √9 is 3. So this is -8 plus, multiply, 15I. Do not combine them. They are not like terms. That's the best we can do. Alrighty. Let's go on to actual problems with I. Let's go into addition/subtraction with I. Addition is very straightforward. They're both very straightforward. Addition's easier though. So addition, let's have 10 minus 2i plus 4 plus I. It's in parentheses there just to kind of keep each section separated. You don't really need the parentheses there. Feel free to take it out if that bothers you. Just rewrite it without parentheses. You always want to do the whole numbers first. So this is 10 plus 4, so that's 14. And then this is negative 2 plus 1. So negative 2 plus 1 would be negative 1i, or you could take off the 1, right? It's implied 14 minus I. And you always want to do the real number and then the imaginary. That is just kind of standard form. I don't really know why that is. It just is. Okay, and subtracting is pretty much the same thing, just one step harder. Let's do that exact problem, but subtracting. So I just changed that middle sign there. You want to distribute that negative through the second parenthesis. So that'll be negative 4 minus minus will be plus I, and then just drop the first one. And I do take it out of parentheses. They're really not needed anymore. They were just there to separate things. And now let's do the whole numbers. So 10 subtract 4 is 6. Negative 2 plus 1 is... did I mess that up? Why is it the same as the first? Oh, I had a different sign. It's fine. Negative 2 plus 1 is negative 1i, or again, you can take off the 1. Okay, I accidentally messed, like I didn't do the exact same problem. So let me go back. On the first problem, this was a plus right here. So let me do that again. Distributing the negative, this would now be negative I. 10 minus 4 is still 6. Negative 2 minus 1 is negative 3i. And again, real, imaginary. Okay, that's how you do addition and subtraction. So subtraction, though, just remember, distribute that negative through the back and then go. Multiplication. Okay, so let's do 10i, 4 plus 3. So this is distributing here. Distribute. So that would be 40i. Distribute. That would be 30i squared. But remember, I square is our superhero. Take him out of his costume, and that's really negative 1. Multiply. So that's 40i, subtract 30. And then even though this is the answer, it's better if we put the real number first and then the imaginary. That would be the best answer right there. Okay, that's the distributing. Right, before I show you the next one, I want to show you just a little bit more about that superhero and like more iterations of him. So real fast, again, I is root negative 1. So that was just I, right? That's I to the first, which is just I squared is root negative 1 squared. So that's negative 1. I cube is I to the first times I square. So that's I times negative 1, which would be negative I. And I to the fourth is I square times I square, which is negative 1 times negative 1, which is 1. And then this pattern repeats. So I only goes like that. It just repeats and repeats and repeats. So example, if I were to do I to the 50th, I would say, how many 4s can I get out of that? That's really I to the fourth. And why do we pick the fourth? Because it's 1. 12 times, right? Because that's 48. And then 2 more to make 50. So this will be 1 to the 12th times I square, but this is just 1. So this is just I square, which is negative 1. So I to the 50th is negative 1. So I basically divided it by 4 and found the remainder. Okay, I'll show you one more like that, and then I'll get to a multiplication example. So let's do I to the 17. So again, divide that by 4. And why 4? It's because I to the 4th is so pretty. It's 1. So if we did I to the 4 to the 4, that's 16. So then there would just be 1 left over. Well, this is 1 to the 4th, which is just 1, times I to the 1st, which is just I. So I to the 17th is I. So again, you're really just dividing it by 4 and seeing what's left over. So that being said, my next multiplication problem is going to be 6i times 5i times root negative 3. No, negative 16. How about that? So that's 6i times 5i times, this is really root negative 1, root 16. So I 4. Now that looks bad. So let's say that's 4i. And there we go. Now multiply all the numbers as normal. 6 times 5 is 30. 30 times 4 is 120. And 1, 2, 3. So that would be I cubed. But in our little pattern that we just had, I cubed is really negative I. So this is negative 120I. All right, what if we're multiplying and we need to FOIL? All right, so let's do 5 plus 2i negative 1 minus 6i. So that is being multiplied. FOIL as you normally would FOIL or box method. I call it the rainbow sometimes. Multiply. 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 I squared is negative 1. Negative 12 times negative 1 is 12. Negative 5 plus 12 is 7. You owe me 30. You owe me 2. You owe me 32i. That is how you FOIL. I'll do another one. Negative 3 minus I. 4 plus. Okay, on the green one, negative 3 times 4 is negative 12. Negative 3 times 10i would be negative 30i. That would be negative 4i. And that would be negative 10i squared. But I squared is negative 1. Negative 10 times negative 1 is 10. Negative 12 plus 10 is negative 2. You owe me 30. You owe me 4. You owe me 34. Okay. And then I guess the only one I'd like to do is if it's squared. So, if it's 3 plus 2i squared, just rewrite it. 3 plus 2i, 3 plus 2i. Don't try to do it without rewriting. 9, 6i, 6i, 4i squared, but he's our superhero, negative 1. 4 times negative 1 is negative 4. 9 minus 4 is 5, and this would combine to be 12i. So just if you do get that square, just rewrite it real fast and then FOIL it out. And now the worst one, division. Okay. Let's start with 5i over 10i. I can cancel, just like x's can cancel. This would cancel. 5/10 is a half, right? That's not too bad. Right? What if there's just an I on top? That's fine. This reduces 5/10 is a half and leave the I on top. That's fine. Where we get into trouble, and this is just a rule, is that we cannot have I on the bottom. It is just not considered proper. Right? So if we have, I don't know, 12 over 4i, you can go ahead and do 12 divide 4 like you normally do. That's 3. But then you'll still have I. You're going to bounce it. This is not a technical term. It's just what I call it. You're going to bounce it by multiplying top and bottom. That's 3i, and that's I squared. But I square is -1. 3 divide -1 is -3i. Answer. So we're not actually solving anything. The directions on this would be like simplify. You are getting the I off the bottom by multiplying by I. Okay, let me do one more of that. Let's do 9/4i. So that does not reduce, which is fine. So you can just go right into multiplying by I, top and bottom. That's 9i, and that's 4i squared. But I square is really -1. And there we go. You could leave it like that, or I just personally prefer the negative on top, or you can put the negative on the side like that. Oh, sorry. I's in the wrong spot. Either one, all three are correct. I prefer this one, but that's just me. I just like negatives on top. It can be anywhere as long as it's there. Okay, so that's how you'd like just divide kind of single i's. What if it's like worser? What if it is 10 over 2 plus I? Don't do 10 divide 2. If you were going to do that, you'd have to do 10 divide I, and we don't want to get there. What you're going to do is you're going to multiply this whole shebang, not by I. That won't help you eliminate it in the bottom. You're going to multiply by the conjugate. And that is just a fancy word for the bottom exactly how you see it, but change the sign. So keep the 2, keep the I, change the sign. And then you got to do the same thing on the top to be fair. So on the top, you're going to distribute 10. So 20 minus 10i. And on the bottom, you're going to FOIL these out. So that's why you have to learn multiplication before division. 2 times 2 is 4, minus 2i, plus 2i, minus I squared. The middle should always cancel. That's the beauty of the conjugate. That's why this works. This should cancel out. So we have 4 minus, this is -1 in disguise. So we have 4 plus 1, which is 5. All right, we've done it. We've got the I off the bottom. You would think we're done, and sometimes you will be. But look at this one. We can actually divide by 5. 20 divide 5 is 4. -10 divide 5 would be -2i. And that's like a simplified form. You won't always have that happen, but we'll take it when it does. Okay, let me show you that again. And then I'm going to make it one step worse, and then I'm going to call it a day here. Let's do -6, 7 minus I. So again, when it's not just a regular I down there, when it's got a symbol like a plus or minus, the only way to get that off is to multiply by the conjugate. So you're going to keep the 7, keep the I, change it to a plus. And you got to do the same thing on top to be fair. Distribute is -42, -6i, there's your top. And the bottom, you're going to FOIL out. 7 times 7 is 49, plus 7i, minus 7i, minus I squared. The middle should always cancel out, or you've done it wrong. That's the whole point of the conjugate. So we have 49 minus -1, because again, he's a superhero. That's going to turn to a plus, and we're going to have 50 on the bottom. Now again, sometimes you might be done, but since all those numbers are even, we can go ahead and divide by 2, just to reduce this down. That's slightly better there. Okay. So that was one application of the conjugate. And now there's pretty much the same application. The math's just going to be a little bit worse here. Okay, what if it's 4 plus 3i, 5 minus 2i? Really the same thing we just did. The I is fine on the top. It's the one on the bottom that's an issue. It's just not allowed. So you're going to multiply by the conjugate of the bottom. Make sure you're always kind of focused on the bottom to get you started. I'm going to keep the 5. I'm going to keep the 2i. I'm going to change the sign. And I'm going to do the same thing to be fair. We're going to FOIL on the top. So that's 20, 8i, 15i, 6i squared. So that's going to be -1 in disguise. 6 times -1, so that's -6. 20 minus 6 is 14. 8 plus 15 would be 23i. There's the top. And now FOIL out the bottom. 5 times 5 is 25. That would be plus 10i minus 10i minus 4i squared, but that's really -1. Negative times negative, that's really plus 4. 25 plus 4 is 29, and this should cancel, and it does. Top is fine. This one does not simplify down. There's the answer. Woof! I'll do one more, and then I'm done. This is about as hard as I division gets. Again, this is for like an Algebra 2 class. Let's do 11 minus I 8 plus 3. To get it off the bottom, we're going to multiply by the bottom's conjugate, which is a fancy word for keep what you see, flip the sign. To be fair, you then have to do it on the top. Foiling out the top, that'd be 88 minus 33i minus 8i plus 3i squared, which is -1, which is -3. 88 minus 3 is 85. You owe me 33, you owe me 8. So you owe me 41i. There's the top. Now FOILing out the bottom. 64 minus 24i plus 24i minus 9i squared, superhero, multiply, +9. 64 plus 9 would be 73, and the middle should cancel. It does. This one does not reduce. Answer. So yeah, it doesn't look pretty, but we succeeded in our mission of getting I off the bottom. I hope this video on operations with I was helpful, and I hope you're having a great day. Hope to see you again soon. Bye-bye.